inflation is amazing. It's amazing with all its incompleteness, and that I think we should be able to celebrate that without pretending other things aren't unresolved.
And so, can we turn to one final topic, because I know that you'll have to go in the not too distant future here. But I wanted to, I'd be remiss if we didn't discuss the multiverse as one of the other features that naturally emerges from many inflationary models and has, polarized over the years physicists regarding whether they're willing to talk about the multiverse, whether the multiverse is metaphysics, whether it's physics. My own view is that it's an interesting idea that we should keep in our toolkit. If inflation truly is right and the simplest of models turn out to be correct, we may need to take the multiverse seriously as a natural consequence. Maybe it's testable. There are indirect ways that in the best of all worlds, it might be testable, but it's very much speculative ideas that we shouldn't just rush toward quickly because it's a radical change in our picture of reality. I mean, how do you come down on the multiverse?
Well, I think a good place to start from my point of view is to say, I think physicists as a whole have a pretty conservative streak. We don't like to embrace radical ideas unless nature is somehow forcing us to do it. We don't want to, if I said, Brian, I want you to hear my theory that the universe is really a rubber duck, you probably aren't going to have time for that. Or you're going to pin me down pretty quick. What on earth are you talking about? But I think with a lot of cosmology, we don't know how to make that conservatism. We don't know how to realize that conservatism. So you mentioned the multiverse, and what I'm imagining, the piece I'm imagining you're referring to is that if you take inflation at face value and you take a simple idea about inflation, you wind up sort of extrapolating in a really simple way and learning that our little bit of the entire universe we see is some ridiculously small part of a much bigger thing. And that seems very difficult to avoid. And I've done some work asking, so what, and that seems radical. Like who needs a theory of the universe that has so much more than what we see? It just seems, and especially there's at least perceived problems that it's actually sort of prevents the theory from having predictive power, and we can get to that. But I've tried to ask the question, what would an alternative be? How could you prevent inflation from generating the multiverse in that way? And you have to do something else really radical. So I'm actually pretty excited about that path, and I'm not. I think that might be, this whole tension might be pointing us in this other path where there's basically a breakdown. I would say, in fact, I think it might be even connected to these entropy things. I think I don't know if we get to use the term phase space or Hilbert space in this conversation, but it's sort of
feel free.
A way to describe, you have a physics theory, and the theory sort of should be able to describe all possible configurations of that theory, and you talk in quantum physics, you talk about the Hilbert space that kind of characterizes all those possible configurations, and maybe not surprisingly, that's connected to entropy because you're measuring the possible configurations that out of all possible, you sort of, it's the context by which you count possible configurations of the system. I'm pretty convinced that the entropy puzzles, the tuning problems, will not be solved with conventional ideas about what the Hilbert space is from quantum field theory or so on. I'm pretty convinced that there has to be something really different to ever solve them, if there is a solution. And so so that could, and certainly these ideas that inflation leads to the multiverse sit very much on a foundation of conventional ideas about the Hilbert space for quantum field theory.